Welcome to this course on prompt engineering. Today, I'm going to give a talk on the evolution of AI from traditional AI to what we now know as generative AI. As we have seen before, AI can generally be thought of as a field of creating systems that can perform tasks that usually human beings are able to do. In other words, systems that can mimic human intelligence. And there are several tasks that we think as associated with human intelligence. Right from being a child, we are able to learn a language, understand language, not just one language, but multiple languages. We are able to recognize patterns. For example, someone goes for a walk every day, things like that. We are able to learn from data. We are able to predict things. We are able to generate content, artistic content, music, videos, and so on. And we are able to support multiple decision-making processes and all that. Now, the quest of AI systems is to see if computers can do all of these things that we do quite easily. And because computers can keep improving in their computational performance and the ability to store data, over a period of time, if we come up with systems that can do what most of human beings can do, then these systems can actually do many things much better than us humans. So the bottom line is AI then would enable machines to uh, perceive, learn, reason, generate, and assist in solving problems that usually we find in multiple fields, in our personal lives, in engineering systems, in sociological systems, and so on. Now, this slide is something that all of us are probably aware of now because I cannot imagine anyone not having heard of AI or why AI matters today. And though you have heard this before in some structured format, the key idea behind AI today is that I can use lots of data that is generated to be able to build models and be able to build reasoning systems that can do the many things that we discussed when I was discussing what AI systems are expected to do in the last slide. The critical aspect of AI systems now, and this is very, very important to understand, is AI systems nowadays work only on data. So if you do not have enough data, you do not have an AI system. So in some sense, you can think of these AI systems as systems that is looking at all the data that is thrown at it, assimilating it, categorizing it, understanding it, and making decisions with those. So that means the prerequisite for AI systems and AI models to be built is the availability of large amount of data. And this has been one big change in the last 20, 25 years because the storage costs have come down dramatically. You have mobile technology where you can generate data at different locations and move them from one location to another. Data is generated from business systems, sensors, smartphones, websites, digital platforms, and so on. So there's a huge amount of data that is being generated. Not only is data being generated, there is also archival data that is out there. Every document that has been created, every piece of music that has been created, every video that has been created, every movie that has been created, it's all out there. All of this is data. So now this huge quantity of data can be used by AI systems to learn and then reason and so on. If you come to the view of organizations, they have been generating data for a long time. In fact, if you go to any government office, you ask where is the data that has been generated before, it is sitting in files, in rooms, and so on. So there are organizations which are highly digitized, which have data sitting in their computers, in Word documents, PDF documents, JPEG images, Excel sheets, and so on. There are organizations which have data in files, right? So there are rooms with files of data. Now, why would someone keep all of this data? So there are many reasons for it. Over a long time in the past, for traceability, for going back and picking something up, and so on. There has been this tendency to collect lots of data. But now that these AI systems can actually look at this data and work with them and do very interesting things, organizations have started asking this question, okay, I have been sitting on this data. I'm not making any useful decisions from this data, or I'm not putting this data to good use. Um, can I now look at AI, which everyone is talking about? AI systems are consuming data and then producing these fantastic results. Is there a way in which my organizational data could be used in an AI system to give me insights that I have been missing? So that is another reason why AI is very popular among organizations. And you will see that many real world problems require prediction. Okay, just take as an example, if you're a farmer, when do you want to add your fertilizer? What is the rain prediction? What is the drought prediction? All of this matter in terms of your crop patterns and what you want to, harvest. When do you want to harvest? What kind of plants do you want to put in your farm? Of those depend on prediction. So AI systems being able to predict is very, very important because you can use these predictions meaningfully to run your businesses better, run your farms better, and so on. And clearly, AI is transforming all fields. It used to be that people used to ask what fields for what fields does AI matter and for what fields does AI not matter. But the answer now is categorical. Every field AI matters. AI has had a tremendous impact in the fields of healthcare, finance, education, transportation, and so on. So in every field, AI systems are important. Now, is this new? Are AI systems something that started recently? Actually, very interestingly, many of the ideas in terms of AI systems, neural networks, neuronal models, and so on, have been around for more than 75 years, starting in the 1950s. The early AI systems were actually rule-based systems. What does it mean? Um, Whenever we think of how we organize our knowledge and make decisions, typically we'll say, okay, if my friends come with me, I'll go to a movie, right? So if you think about this structure, you say, if something happens, then I'll do something. Or if something I observe, then probably this is the cause, and so on. So in some sense, the knowledge that we possess can be written in terms of rules about observations, outcomes, and so on. In 1950s, there was not as much data as we have right now. So there was no possibility of learning completely from data. So the initial thought about AI was I will capture the knowledge in a human being through some rules was the first kind of idea for AI. So you had rule-based AI systems that operated in this framework. As compute started getting better and better and more data started coming into use, then you had machine learning techniques that started. Um, the difference between machine learning techniques and AI is the following. So machine learning techniques, you can think of them as building, most of them as building uh, reasonable sized models that can be used for all the tasks that we talked about before. And because of the transition from rule-based AI to where we were looking at generating this knowledge from just data, So there are also machine learning techniques which will be a combination of rule bases, and then part of the knowledge will be learned from data and so on. So that is a nice transition in terms of the size of the models because the compute was improving, data was improving. So you are transitioning from rule-based systems to machine learning techniques, which will automatically generate models from data. Now, one of the machine learning techniques which was used for a long time were neural networks. Though neural networks were thought of as AI because people understood the potential of this tool, and they knew that the time has to come for these neural networks to really do all that they can do now, which is to wait for computational prowess to keep increasing and the availability of data to keep increasing. So neural networks were already a part of these machine learning techniques, but these were smaller networks, much like a machine learning model. These were smaller networks that people used to train with limited amount of data and then make predictions and so on. Now, with more compute coming into picture, more data being available, these neural networks started becoming bigger and bigger and bigger and deeper and deeper and deeper. What does deeper mean? Initially, we had neural networks with a few layers. Now you can have neural networks with hundreds of layers. So deep neural networks, which have large number of parameters, which can process a large amount of data because such kind of data is available, and compute is also available for this model to be trained. And that was deep learning that started in 2010. And they got so good in natural language processing, video processing, audio processing, and so on, that these networks, with some architectural changes, of course, they're starting to do things that were not possible before with the machine learning models and so on. These kinds of neural networks not only were predicting things very accurately and so on, but they also started creating text, images, codes, and so on. And that whole field is what is called as the generative AI. So these are AI systems that are not just learning from data and then predicting based on the data and so on. They were also, in some sense, extrapolating by generating new content. Systems that could generate documents based on a query, which could generate code based on prompts and so on. So we are now in this era where from generative AI, where these systems could generate uh, answers and text and new material based on human query, we are moving into this field of agentic AI, where the AI system becomes autonomous and they become an agent themselves. So if you want to think about it in a very simple terms, in a simple AI model, a human asks questions and it answers, and human says, okay, can you generate this? It generates and so on. Now think of this AI now becoming autonomous, and it is asking questions itself. It is looking at its results. It is evaluating its results and modifying the results and so on. So it has become autonomous and starting to do things pretty much on its own. And that's a field of agentic AI. And that's where we are currently. Now, the applications of AI are in multiple fields. There are some fields I'm listing here so that you kind of get the feeling of how broad the impact of AI has become in healthcare. Just one very incredible example is that, typically in medicine, uh, personalization is very difficult sometimes. So a very good example is if you have a headache or a fever, most of us will take 650 mg Dolopar. Now, it's not that for everyone you need 650, depending on body mass, height, and so on. Someone might need 650, someone might just need 300 mg, and so on. However, because of the production processes, it's very difficult to personalize and then say, okay, for this person, this is precisely the medicine for them at the right amount and so on. So those kinds of personalization is difficult, but AI systems are making a huge impact in terms of personalization and so on. In the field of finance, there are several applications of AI. AI systems are being used in fraud detection. They're being used in credit scoring, risk assessment for loan approvals, and so on. So, again, the financial systems have kind of well-defined rules and lots of data. So that's a fertile field for AI to play in, because if the uncertainty is limited, and the rules are reasonably well set, and there's a lot of data, AI systems can really do well. Of course, in transportation, self-driving cars is an example where AI has had an enormous impact, but that's a more glossy application of AI and logistics. But behind many traffic management, road optimization, and so on, AI systems have a big role to play. Again, much like how I talked about healthcare, in education also, personalization is very important. So this is another place where AI systems can have a major impact. For example, as a professor, if I go to class and teach, I can't teach for every individual student. I look at an average of the class, and then I teach for the class so that no one is completely left behind, or the brightest students are not bored. Okay, so you have to pick that kind of middle ground where you do your teaching. But imagine if I could sit with every student separately and understand what they know, how do they learn, what is their speed at which they learn, and what kind of pedagogy is better for a particular student, and so on. If I could understand all of this, then I could make each student learn in a very personalized fashion. Now, clearly, one professor going to class cannot do this. But if there are AI systems which then can be made available to the students, so that this systems kind of model how the student is learning and then personalizes that education, that's going to be a big thing, big application for AI. Of course, AI is a very important tool in manufacturing. There are many, many problems where AI can have an impact: predictive maintenance, quality improvement, energy optimization, and so on. There are specific challenges with the use of AI in manufacturing, because in manufacturing, domain knowledge becomes very important. Data is usually residing in silos. And the data might not even be big data like you could have for documents and so on. So if you're training a natural language model on documents, you can get millions and millions of documents. But if you're looking at data for a particular equipment, there might not be enough data for AI in some cases. So there are specific challenges with respect to availability of data being in silos, and heavy dependence on domain knowledge in manufacturing. Nonetheless, there are many, many problems where AI will have an impact in manufacturing. Very quickly, there are other things which we all know. Energy systems automatically switching off lights, coordinating HVAC systems so that the energy is efficiently used is an area AI could have a big impact. All of us are using AI systems in security and surveillance. Anytime you go to airport, there is a face recognition system that allows you to go in. That's AI. In communication, spam filtering, email suggestions. Now, when you're typing your email, there are already suggestions that are coming up. Those are all AI systems. And in media and entertainment, again, recommender systems that you see in OTT platforms are all operating AI models in the background. I talked about the movement of AI from the initial rule-based systems to machine learning to deep learning to generative AI to agentic AI. In that, I talked about machine learning. And machine learning is a branch of AI, as I said before, where the system learns patterns from data. And this was a transition from rule-based systems to fully data-based AI systems when the data was a little limited, or you might think of us going from a data poor time to a very data rich time. So in the middle, you had more and more data coming in. So you could not build very, very large models because there was not enough data to support those models. Nonetheless, there was enough data to automatically identify the rules that AI rule-based systems were using through models and machine learning techniques. So that is the sweet spot of machine learning techniques. And these are very relevant even now because you do not have to look for large AI models for every problem. You can very, very effectively solve a very large number of interesting problems using machine learning techniques. And typically, machine learning techniques solve two types of problems. One is called the classification problem, and the other one is a regression problem. Classification problems are where you are you're classifying a data to a particular class. Very, very standard example is if I give a machine learning system several photos of cats and dogs and let it learn from these photos, and when I show a new photo of a cat or a dog, it should correctly classify it as a cat or a dog. That's a classification problem. Regression problem would mean if I give this model lots of data about used cars and what they were sold for, if this machine learning model builds from this data, when a new used car comes in, it should be able to say what is the cost at which it is likely to be sold. That's called a regression problem. And the machine learning methods are grouped in multiple ways depending on the kind of data that is available and used, the type of model used. It could be a linear mathematical model, nonlinear model, a graph model, and so on. And type of learning. So there are different types of learning approaches. One of the approaches is called supervised learning. Another one is unsupervised learning and reinforcement learning. So these are the different learning methods that you learn. And depending on a combination of these, there are different branches of machine learning algorithms. Of course, as I said before, deep learning is a subfield of machine learning where you're basically building a model. And these models, unlike machine learning models, which are generic form of equations, right? You could say, I'm using a quadratic equation, or I'm using a graph model, and so on. The deep learning models actually take inspiration from how human brain works. In a human brain, there are several neurons, and there are connections between neurons, and the neurons either fire or not fire based on a collective input that they get. So neural networks model this phenomena. And if you do multiple layers of these neurons, and then you're able to train these models, that is what is called as deep learning. And the reason why this is slightly different is that in the typical machine learning models, as I said before, there is no notion of actually a biological neuron that is being modeled. But in a neural network, there is a notion of biological neuron that is modeled, and there is a mathematical model for that neuron. Ultimately, it's all still math, it's all equations that come out. But the perspective that one gets in terms of I'm modeling these neurons and I'm connecting many neurons to model a neural network is very important. And when you have many layers of these neurons, then it is called deep learning. So a quick recap before we step into generative AI and so on in future lectures. AI is the big umbrella under which we operate. And this is where these are techniques that allows machines to mimic human intelligence. Machine learning is a subset of that. And I've explained from rule-based AI to the AI systems of today how machine learning occupies that transition region, and they're still very, very useful. Then deep learning is also a kind of a machine learning model because it's parameterized, there are model equations, but the perspective is that you're using a model of a brain, and that's where the difference is. And finally, these generative AI models are fundamentally deep learning models, but they just don't predict, but they create newer material in terms of text, images, audio, video, and so on. So we have already talked about generative AI, that is intelligence that is capable of generating new content. How does it work? It uses a notion of learning from data and kind of predicting what is the next in a sequence. So if you want to take an example, if I say I want to construct a paragraph, if I start with the first word, then based on the context that I have and the question that I'm trying to answer, based on the first word, there are many words that can come as a second word. Now these systems look at what is the most likely next word. And then once the next word is fixed, what is the most likely word after that, and so on. So if you keep adding most likely words again and again and again, you generate a sequence of words which can then become lines, paragraphs, and so on. So that is AI system that answer queries in text and so on. You could also think of generating an image in the same way. So just as an example, just to make some of these ideas clear, if you think of image as multiple pixels, and if you say I want to go from left to right, if I give a pixel, what is the most likely next pixel and next pixel and next pixel and so on. That way you can string together an image. And once you string together an image, you can string together using the same idea, videos, and so on. The same ideas will work in audio also. If you have a sequence of frequencies, then you could say, well, this frequency followed by the next frequency, and so on. So there are all of these things that are possible within this framework of generative AI. So in text, summarizing text, answering questions, translating, taking speech to text, and so on. All of these are things that Gen AI can do. Now, Gen AI tools have become incredible at generating code, and Claude is an example of a system that generates really sophisticated code that can come out of these systems. You can generate images, audio, video, and so on, as we discussed. So we've already discussed AI, ML, deep learning, generative AI, and so on. What next? An AI system is sitting. Unless you ask a question, it's not going to do anything, right? So what does it mean when we say we can generate content using these Gen AI systems? How do we communicate clearly with these Gen AI systems? Because remember, the way I explained how the AI systems generate new stuff is through this completion, right? You might call it statistical completion. So if you're generating text, you might say there are a sequence of words, and then what is the next word? So you find many words that could follow it. You kind of pick the highest probability word, and so on. So the highest probability word depends on many things, including the context, the question that you have asked, and so on. So if you don't ask the right questions, then this whole process can give you new material that could be simply not very factual. It could be something that you don't want because you've not been able to ask the right question, or it could just be what is called as hallucination, where the systems make up some answer which might not be true at all. So the way we communicate with these Gen AI systems is critical, and we communicate with these Gen AI systems using these prompts. And so it's very important to understand what a prompt is and why does it matter in terms of your ability to use the Gen AI systems to the best possible uh, outcome for whatever you're trying to do. So this whole course is actually around this notion of prompt engineering and how do you interact with these systems so that you get the best out of it, reducing hallucinations, maybe reducing other uh, uh, responses that might not be very relevant, and so on. So that's what you're going to see. So to recap, Gen AI systems are where we are now, and we are moving more and more towards agentic AI systems. So Gen AI systems, we prompt, and even in agentic AI systems, though agentic AI systems will do a lot of things in an autonomous fashion, there's still a human in the loop who's going to structure these systems to give the output that they desire. So those are things that you will see in future lectures. And I hope some fundamental background was, given to you through this lecture. And the future lectures will get more into the Gen AI and prompt engineering, and you will be able to learn how to work with the systems so that you become productive. Thank you very much.